The engines in today's Ford cars and trucks represent major improvements in powertrain technology. As part of our commitment to continuous improvement, Ford Motor Company is adding new subsystems and better engine designs with features such as variable cam timing that contribute to improved performance and fuel economy. These sophisticated power plants use precision components and have tighter tolerances that require cleaner operating conditions and a cleaner manufacturing environment. Additionally, many of our older engine architectures have been sources of customer concern because of contamination from known and unknown sources. When the moving parts of today's engines are exposed to contaminants, there is a greater potential for engine noise, component damage, or even complete engine failure. Even the smallest piece of debris can cause serious damage to components such as these crankshaft bearings. For example, these small dots are contaminants that have been compressed into the bearing. They can cause friction and heat, leading to delamination of the bearing. Damage like this produces expensive warranty claims, as well as customer dissatisfaction that ultimately threatens everyone's job security.
It is absolutely paramount for us as an organization to improve our quality, or we will go out of business. There's no doubt in my mind. Controlling contamination is a key element of improving our quality. I'm absolutely convinced of that, and I've seen it through my experience in the organization.
Although our warranty performance of our engines is very good, we also know from the engine teardown data that we do get that over 10% of our failed engines has the potential of being due to contamination.
The products today, we know that a 50 micron particle, which is really teeny tiny, can actually cause a bearing failure, can cause an engine failure, can cause a dissatisfied customer, can cause a lost customer along with all their neighbors and friends. So we, more than ever, have to be very serious about the cleanliness of the products that we build.
We know that contamination has the ability to affect the customer and to impact the things that we work very hard to improve every single day. It no longer is just someone else's job to fix contamination.
Our quality metrics have improved year over year the last couple of years pretty substantially. And I personally believe a big part of that is the improvement in our contamination, or the reduction in our contamination.
Since debris is most likely to find its way into an engine before it's assembled, it's important for you and everyone involved in the plant, machining, assembly, support processes, and suppliers, to do your part to prevent engine contamination. While contaminants are ever present and can come from almost anywhere, the contamination sources of greatest concern are found in the manufacturing process, work environment, gloves, washers, and dunnage. During the manufacturing process, metal shavings such as these can cause severe damage or even complete failure if they get inside of an engine. Since metal debris is always present during machining, every precaution must be taken to prevent these contaminants from coming into contact with finished parts. When contaminants are found on a finished part, it is important to trace the problem back to the root cause. Each of these bags identifies a specific contaminant and its source, helping engineers and work groups to establish the cause and correct the problem. It is a recommended practice to display and label the various types of shavings that can come from each workstation. Doing so gives a work group a visual aid which helps them to readily identify a contaminant source. Another recommended practice is to develop a contamination identity catalog for lab reference. Cataloging pictures of different contaminants from both a microscopic and naked eye perspective helps employees recognize the various types of contaminants and their sources, as well as to recognize when a change has taken place. For example, an increase in the size or amount of debris may indicate that a cutter requires maintenance or replacement. All cutters require periodic maintenance in order to ensure precision component surfaces and minimal contamination. In this example, a worn cutter is being replaced with a sharpened tool to ensure component integrity. All cutting and grinding tools should have change schedules. They should be replaced when worn beyond specification.